In this video, I want to show you how a binary search works. So here's an array of 13 elements, which means the first index is 0 and the last index is 12. Now, binary search depends upon tags. And we actually create 3 different kinds of tags. We create a left tag, a right tag, and then from those 2 tags, we calculate a third tag called midpoint. So this is how it works. First, here's the initial setup. Left becomes index 0. Right becomes 1 less than the array length. And the calculation of midpoint is always going to be the average of left and right. That's a calculation that we constantly calculate throughout the method. So 0 plus 12 is 12. 12 cut in half is 6. And so what we have is that midpoint is index 6. Here's the search value. We want to look for the number 89. And so what I'm going to show you now is the core logic of the binary search. This process is going to be inside of a while loop. And what happens is that if we can't find the value, if the value we're looking for isn't in the array, then what will eventually happen is the left tag will become greater than the right tag, in which case we return a -1, which is how we indicate that the value wasn't in the array. Also, before I show you the code or the logic to this process, you need to know that binary search will not work unless your array is already sorted in ascending order, meaning values go from least to greatest. That's key. If you don't have a sorted array in ascending order, binary search is not going to work. Here we go. Here's the core logic. The first thing I do is I compare the array at midpoint index to the search value. If they're equal, hey, I'm done. Just return that index of midpoint. If, however, the value at midpoint is larger than search value, what I'm going to do is I'm going to reposition the right tag. And I'm going to actually place it to be 1 index before midpoint. And it's going to be just before midpoint because there's no point in searching at midpoint. And so right would become index 5 in this case. There's a 5 before the 8, but don't confuse that value 5 with its index. Its index also happens to be 5. But you can clearly see that that's not what we have here. The value at midpoint is 8. And since my search value is 89, 8 is clearly less than 89. And what that means is that I'm going to reposition the left tag. I'm going to set its position to be 1 index greater than midpoint. Once I do this, I recalculate the new index for midpoint. I take left plus right divided by 2. So currently left is at index 7 and right is still at index 12. Now you got to remember this is integer division. This is not your typical calculator division. So if I take 7 plus 12, I get 19. Cut that in half, I don't get 9.5. This is integer division. There is no decimal. So in other words, I only get the integral portion. So I'm going to get 9. So in this case, midpoint is calculated at index 9. And then I just run through the comparison again. Is the value at midpoint greater or equal to, is it equal to search value? Well, clearly 34 is still smaller. What does that mean? That means that I'm going to ignore everything before that and reposition left to be 1 index greater than the previous midpoint. And now we recalculate. So left is at index 10, right is at index 12, the average is 11, midpoint, bam, is at 11, and guess what? 89, I found it. And so I'm going to return index midpoint, which is 11. Now if 89 wasn't in the array, what would have eventually happened is left would have become on the right-hand side of the right tag, or right would have gone on the left-hand side of the left tag, in which case, return a -1. This is binary search. It's controlling tags, a left and a right, and then calculating a midpoint. And you know what? It's really, really fast. If you have a small array, like 100 or so elements, use linear search. There's no reason to use binary search. But once you start getting into the tens of thousands or millions, binary search is the way to go. I just want to reiterate this one more time because it's just so important. It's so critical. If your array is not already sorted in ascending order from least to greatest, binary search is not going to work. That's how it works. God bless you, wherever you are today.